Hi guys, we're going to continue in our solving of quadratic functions. We've actually skipped over section 9.4, which is solving by completing the square. And we're going to move on to lesson 9.5, which is solving quadratics using the quadratic formula. So let's take a look at that. Quadratic formula is great to use because it can be used to solve any type of quadratic function in the world. We can solve by factoring. We can solve by square roots. We can solve by graphing. And we can solve by quadratic formula. But quadratic formula is one of the only techniques besides completing the square that works for every single type of quadratic function. That's why we like it. So here is your quadratic function. One of the most important things in algebra is something called the quadratic function. So quadratic formula, not quadratic function, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our function, our quadratic formula, I should say. A couple ways you can remember this. There's lots of different songs and techniques to remember the quadratic formula. I learned it with Jingle Bells back when I was in high school. So it was something like opposite of b plus or minus root b squared minus 4ac all on top of 2a. So that's how I learned it. Some people learned it with the Pop Goes the Weasel. So the Pop Goes the Weasel song goes something like, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So now you got to hear my wonderful off-tune, terrible singing. I'll never subject that to you again. But maybe it'll be stuck in your head forever now, and you can remember the day that Mr. Rosenblum sang the quadratic formula to you in both Jingle Bells, opposite of b plus or minus root b squared minus 4ac all on top of 2a, or Pop Goes the Weasel. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we can move on. Let's look at an example now. So when we're dealing with the quadratic formula, which we see up here, we want to identify what our a, b, and c terms are. So here's a, here's b, here's c. So a is equal to 2, b is equal to negative 5, and c is equal to 3. So we're just going to plug into our formula now. X equals opposite of b, or negative b. Well, my b is already negative, so when I take the opposite of it, it's going to become positive. So opposite of b plus or minus root b squared, so negative 5 squared, minus 4ac, 2 times 3, all over 2a. So 2 times my a term. So there's the quadratic formula with all the numbers plugged in. Now let's do the math out. So x is equal to, we're going to do what's inside our square root first. So 5 plus or minus square root of negative 5 squared, which is 25, minus 4 times 2 times 3. So that's going to be minus 4 times 2 is 8 times 3, so 24, all over 2 times 2, so all over 4. You could enter what's underneath the square root into the calculator to get that value, but you don't want to put everything in all at once because you'll probably make a mistake. Now, x is equal to 5 plus or minus 25 minus 24 is going to be 1, so the square root of 1 over 4. Let's keep going here. What is the square root of 1? Well, the square root of 1 is just 1. So now I'm going to have x equals 5 plus or minus 1 over 4. Let's write our two cases then. Now, sometimes what's underneath that square root right here is not a perfect square, and you'd be done right there. But this is a perfect square, so we can continue going. So we're going to have 5 plus 1 over 4 and 5 minus 1 over 4. And this is what x is equal to. So x is going to be equal to 6/4 or 3/2. And then 4 minus 4, x is going to be equal to 4 over 4, which is just equal to 1. So x equals 1 is our other solution. And now we've solved our quadratic equation. We're solving for x, that's the whole goal, by using the quadratic formula. I'm going to do one other example. I'm going to do number 4 on this slide, because you'll notice that it's not equal to 0 first. You always have to make it equal to 0. So we're going to add the 1 to both sides. Now we're going to be left with 4x squared minus 4x plus 1 is equal to 0. Let's run our quadratic formula. So x is equal to 4 plus or minus the square root of negative 4 squared minus 4, a lot of 4's involved here, times 4 times 1, all over 2 times 4. What you'll notice here is that inside your square root, you end up getting x equals the square root of, I forgot my 4 plus or minus on the outside. So 4 plus or minus the square root of 16 minus 16, all over 8. So you end up getting x equals 4 plus or minus the square root of 0 over 8. Well, the square root of 0 is just 0. There's only one solution here. So I end up getting x equals 4 plus or minus 0 over 8. Well, 4 plus 8, or 4 plus 0 and 4 minus 0 is just going to be 4. So you get x equals 4 over 8, or x equals 1/2. And that's our answer. So there's just one solution here, which does happen sometimes. Let's take a look at this word problem here. So it says the number y of Northern Rocky Mountain wolf breeding pairs x years since 1990 can be modeled by the function y equals 0.20x squared plus 1.8x minus 3. When were there about 35 breeding pairs? They're actually giving us a y value equal to 35. We'd have to take that y value and we'd have to plug it in to our function. So we're going to end up getting 35 equals 0.2x squared, 0.2, plus 1.8x minus 3. So step 1 is going to be to subtract that 35 to get it equal to 0. So let's get rid of that. So the function that we're actually solving here is 0 equals 0.20x squared plus 1.8x minus 38. Let's run our quadratic formula. X equals opposite of b, so negative 1.8 plus or minus the square root of 1.8 squared minus 4 times 0.2 times negative 38 all over 2a, so all over 2 times 0.2. Got to use a calculator here, no other choice. Inside my square root, what I end up getting is 1.8 squared minus 4 times 0.2 times negative 38. I end up getting an answer of 33.64 inside the root. And this is all over 2 times 0.2, which is going to be 0.4. Again, I have to use my calculator to get my two solutions. I'm going to get x equals, if I do that square root out, negative 1.8 plus square root of 33.64 is 5.8. So 5.8 over 0.4. And then I'm going to have x equals negative 1.8 minus 5.8 over 0.4. Let's do that math out. Negative 1.8 plus 5.8 divided by 0.4 gets me an answer of 10. So I get an x value equal to 10. I'm going to rewrite that over there. And then this is going to get me negative 1.8 minus 5.8 divided by 0.4, negative 19. So I have x values equal to 10 and negative 19. Now, if we're talking about the number of breeding pairs, obviously that can't be a negative value. So my answer is x equals, or rather the number of years, I should say. We can't have negative 19 years, so my only answer here is x equal to 10. Obviously, if we change it to 60 breeding pairs, you can just go about doing it by plugging 60 in for y, and then we don't need to go through the same example. We have this thing that's called a discriminant. The discriminant is just the b squared minus 4ac part. And by just looking at that part, we can look at and determine a bunch of different things. We can determine the number of solutions or x-intercepts that a graph or a quadratic function has. If your b squared minus 4ac is positive, so if we have a positive b squared minus 4ac, then your quadratic equation or function will have two real solutions and will have two x-intercepts. If your b squared minus 4ac is equal to 0, then your vertex is your x-intercept, and there's only one real solution here. And if your b squared minus 4ac is negative, meaning it's less than 0, your graph never crosses the x-axis. There are no real solutions. There are no x-intercepts. So you want to know that b squared minus 4ac is what's called the discriminant. And based off of the discriminant, whether it's positive, equal to 0, or negative, we can determine the number of solutions. So let's look. Determine the number of real solutions. This is the number of real solutions because when you get to Algebra 2 and down the road in your math career, you'll learn about imaginary numbers. So let's look at x squared plus 8x minus 3, and we're just going to look at the b squared minus 4ac part to determine where it falls in. So here's your b value, and here's your a value and your c. So when we do b squared, 8 squared, so the discriminant is equal to 8 squared minus 4 times your a value. There's nothing there, so it's a 1 times negative 3. So it's equal to 64. Negative 4 times 1 times negative 3 is going to be a positive 12. It's equal to 86. 86 is positive. So that's a positive value. So we know that there are two real solutions. I don't know what the solutions are, but the discriminant can tell me that there are two real solutions here. Let's look at 9x squared plus 1 equals 6x. So first we have to write it in standard form, which is shown right here. Now that it's in standard form, we can go ahead and we could use the discriminant to determine the number of solutions. So we're going to do b squared, which is going to be negative 6 squared, minus 4 times a, which is 9, times 1. Negative 6 squared is 36. So we get 36 minus 4 times 9 times 1, minus 36. The discriminant is equal to 0 here. What is a discriminant equal to 0? Don't be confused here. Discriminant equal to 0 is our middle case. That's one real solution. So there is one real solution here to this. When your discriminant is negative, that's when you have no real solutions. I don't think we need to go through these examples. I think you have the idea of the discriminant. If you're asked to find the x-intercepts, the number of x-intercepts, that's the number of solutions. Remember, we've talked about numerous times that those words are synonymous. They mean the same thing. So if we want to find the number of x-intercepts, we'll just find the discriminant. The discriminant is going to be equal to here, opposite of b, or sorry, not opposite of b squared. So 3 squared minus 4 times a times c. So my discriminant is going to be equal to 9 minus 4 times 2 times 9, so 8 times, we've got 9 minus 72. That's going to be equal to negative 63. So my discriminant is equal to a negative. So because my discriminant is equal to a negative, there is no real solution to our values. So this would be greater than 0 is your 2 real, 1 real, and then no real. So make sure you know that. Oops, I reversed them. So this should be 2 real when it's positive, no real when it's negative, and then 1 real when it's equal to 0. Okay, don't need to go through these. So one important thing here is we've talked about the different methods for solving quadratic equations. We did factoring. That was one of the most important things you'll learn in Algebra 1 is factoring. Then we looked at graphing. Then we looked at using square roots. We didn't do completing the square, so we're going to cross that guy out. And then we did the quadratic formula. So let's talk about some advantages and disadvantages of all of them. Factoring is one of the most important ones, probably the most important one. It's good because it's straightforward. However, some things are not factorable. Advantage of graphing, you can easily see the number of solutions. You can approximate them. You can use a graphing calculator or Desmos, but it may not give the exact number. And we've seen that when you have to kind of estimate where it crosses. Some of you talked about that on the skier example, the skier assignment we did. Square roots, they're great, but they can only be used for certain types of equations when you have them in the form x squared equals a number. Quadratic formula can be used for any quadratic equation. That's the good thing about it. It gives the exact numbers as well. It doesn't round. Problem, it takes time to do. So you always want to kind of think to yourself, okay, what type of technique do I want to do when I'm dealing with these? Now, you can always graph them, and you can use Desmos when you're at home, but keep in mind on a standardized test, you might not have Desmos. So just be aware. You want to look and you want to say to yourself, okay, what can I do? So first thing, no matter what, you want to set it equal to 0. So let's set this equal to 0. Minus 1 is equal to 0. Just by looking right away, I know factoring is not going to be an option. So I'm either going to graph this. I know square roots isn't going to work here because it's not in that form. So I'm either going to graph or use quadratic formula. I know factoring doesn't work because there's nothing that's going to multiply to -1 and add to -10. So factoring's out, so I'm probably going to use a quadratic formula because it's not factorable. And I don't feel like graphing. So I'll use a quadratic formula. X equals -b, so 10 plus or minus the square root of -10 squared minus 4 times a times c all over 2a. I'm not going to go through this process of actually finding them or finishing this problem, but you know how to do that because we did that this whole lesson. Let's drop down to c. C, I'm going to say to myself, wait, is there something that multiplies to this and adds to this, which is what I do with factoring? And I hopefully am thinking to myself, wait, 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. Yes, this factors. So I can factor this to x plus 6, x plus 2 is equal to 0. You always want to factor because factoring is the easiest thing to do. Now set them both equal to 0. So x plus 6 equals 0. Subtract the 6, subtract the 6. X is equal to -6. Subtract the 2 here, and x is equal to -2, and boom, I'm done. Would the quadratic formula work? Sure, definitely would work. Would graphing work? Sure, definitely would work. Okay, but you want to pick the best technique. So here I'm going to pick factoring because it was factorable. What am I going to do on B? I might think to myself, let me graph this. So I can't show you the graph of it in this form, but I might graph this and say, what does this look like? So I'd use my Desmos and I'd take a look at the graphs and see where if it crosses the x-axis anywhere, and it does. So I'm going to use graphing here because I don't want to factor, and I'm tired of using the quadratic formula. It takes too long. So I'm going to graph. I'm going to get an estimate of my values by looking at the graphs and where it crosses the x-axis here. And if I do graph these, I'm going to get an x value equal to -1.5, which works out nicely, which means it probably was factorable. And I'll get a second x value at, let's see, got to look at my graph, hold on. Get a second x value at 8. And these guys are my x-intercepts, which are also my solutions. All right, so that's all for this lesson. Make sure you know the quadratic formula. Again, hopefully you've remembered it by my singing. Quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Or, jingle bells, opposite of b plus or minus root b squared minus 4ac all on top of 2a. But whatever it is, make sure you know the quadratic formula and how to solve using any of these techniques here. Have a great day, guys. I'll see you.